Now again one more problem, engineering mechanics by Professor Timoshenko, Professor D.H. Young, Director J.B. Rao, Sukumar, Pati. Let me go quickly to problem set 2.3. This is 2.3 and solution to 2.26. Very simple. Just look at the diagram. This is a load, vertical load P, means the load is acting vertically downward, and this AB is a rod and BC is a string, and the load is suspended and it is in equilibrium, right? What axial force does the vertical load P induce in the members of the system? What are the members of the system? The system consists of a string BC and a rod AB. Induce in the members of the system shown in figure E, neglect the weights of the members themselves and assume an ideal hang at A and a perfectly flexible string BC. Means the string does not have any weights, massless string, and this connecting rod is also doesn't have any weight. So let us begin. BC is equal to a string. Therefore, the axial force, tension force, will act away from the point B, that is to this side. Let it be S1, which I have shown in a different diagram below. Will act away from the joint B. Now, if you again look at AB is a rod. Therefore, the axial force, as you know from theory, it will be a compression force. It will act from the point A towards the point B, means to this side, and let it be S2. So let us draw the free body diagram at point B and apply Lami's theorem. So this point B is same thing as this point B. This S1 tension force is shown here, angle alpha. The same angle is alpha here. The force of compression from A to B, that is towards the point B, towards the point B is this one. Given a force, you can, given a vector quantity, you can shift it parallel to it without changing the direction, right? So I am showing S2 from here to this side, right? Here you might be asking, it was towards B, then how it is shown like this? If a vector is represented by an arrow like this, this can be shifted. That is the principle of vectors, right? So at point B, we have three forces, S2, S1. S1, the tension force, S2, the force of compression in the rod, and P is the load. This angle is alpha. So this angle will be 180 minus alpha. This angle is 90, and this angle will be 90 plus alpha. So that is what I have written by applying Lami's theorem. P over sine 180 minus alpha is equal to S1 over sine 90 is equal to S2 over sine 90 plus alpha. That's all. Now, where S1 is the tension force, S2 is the force of compression. Now, if you take the first, if you take P over sine 180 minus alpha is equal to S1 over sine 90 and cross multiply, you get S1 is equal to P sine 90 over sine 180 degree minus alpha. Sine 90 is 1, so sine 180 minus alpha is sine alpha. This can be written as P into 1 over sine alpha. 1 over sine alpha is cosecant alpha. So your S1 is equal to P cosecant alpha is one answer. And if you take the equality, P over sine 180 degree minus alpha is equal to S2 over sine 90 minus alpha from trigonometry, We know sine 180 minus alpha is sine alpha, sine 90 plus alpha is cosecant alpha, cosec alpha. So if you cross multiply, S2 is equal to P cos alpha over sine alpha, and cos of alpha over sine alpha is nothing but cotangent alpha, cot alpha. So S2 is equal to your P cot alpha is your second answer.